Good day, everyone. I am Reina Marie de Bisaya, and I'm going to discuss the selected items from our final problem set. For Chapter 3, Lesson 1, the indeterminate form 0 over 0 and Cauchy mean value theorem and other indeterminate forms. So we have here our first item, the limit of the function x raised to 9 minus 1 over x raised to 5 minus 1 as x approaches to 1. So for our solution, the limit of the function x raised to 9 minus 1 over x raised to 5 minus 1 as x approaches to 1. So we are going to substitute x equals to 1. So it will become 1 raised to 9 minus 1 over 1 raised to 5 minus 1, and that is equals to 0 over 0. Since the limit is indeterminate, so we are going to apply the L'Hopital's rule. So we are going to find the derivative of the numerator and the denominator. The derivative of the numerator, x raised to 9 minus 1, is 9 times x raised to 8. And the derivative of x raised to 5 minus 1 is 5 times x raised to 4. And we are going to substitute x equals to 1. So it will become 9 times 1 raised to 8 over 5 times 1 raised to 4, and that is 9 over 5. The limit of the function x raised to 9 minus 1 over x raised to 5 minus 1 as x approaches to 1 is equals to 9 over 5. Therefore, the limit exists. For item number 2, we have the limit of the function the square root of x squared plus x minus x as x approaches to infinity. For our solution, we have the limit of the function the square root of x squared plus x minus x as x approaches to infinity. So we are going to apply the direct substitution. So this will become the square root of infinity squared plus infinity minus infinity, which is the final answer is infinity minus infinity, and that is indeterminate. L'Hopital's rule is not directly applicable to infinity minus infinity, so we are going to resolve it by rationalizing. The limit of the function the square root of x squared plus x minus x as x approaches to infinity. What techniques can we use to get the answer? First, we are going to combine a single fraction. So by now, the denominator is 1, and we are going to multiply the numerator and denominator by the conjugate of the numerator, and that is the square root of x squared plus x. Instead of minus x, that will become plus x. So what is in the numerator, that is also for the denominator. The square root of x squared plus x multiplied to the square root of x squared plus x is x squared plus x. We just use the property of square root. And negative x times positive x is negative x squared, and the denominator is square root of x squared plus x plus x. Now the terms x squared will cancel, and we are going to have the limit as x approaches to infinity. X on the numerator divided by the square root of x squared plus x. Now if we are going to substitute infinity, we are just going to have infinity over infinity, which means that we can use L'Hopital's rule. But I already tried L'Hopital's rule, and for this function, it is like a never-ending process. So we are going to do something else. Let us multiply the numerator and the denominator by 1 over x, and let us see what's going to happen if we do that. X multiplied to 1 over x is x divided by 1 over x times the square root of x squared plus x plus 1. Let us put 1 over x inside the square root. 1 over x is the same as the square root of 1 over x squared, so we can replace 1 over x by the square root of 1 over x squared times the square root of x squared plus x, so that we can multiply 1 over x squared by the x squared plus x, and that is square root of 1 plus x divided by x squared, which is 1 over x. So we have now the limit x divided by the square root, the x squared, which will be multiplied by 1 over x squared inside the radical, is going to turn to 1, and x times 1 over x squared inside the radical will become 1 over x plus 1. Now at this point, we can apply the direct substitution. The limit of the function 1 over x, the square root of 1, plus 1 over x plus 1 as x approaches to infinity. For constant divided by a variable, that is going to be 1 over infinity, which is equals to 0. So this will become 1 over the square root of 1 plus 0 plus 1. 1 plus 0 is 1, and the square root of 1 is 1. And 1 plus 1 is 2, and the final answer is 1 over 2. The limit of the function, the square root of x squared plus x minus x, as x approaches to infinity, is equals to 1 over 2. Therefore, the limit exists. For Chapter 3, Lesson 2, Improper Integrals with Infinite Limits of Integration and Other Improper Integrals. For our third item, we have the integral of dx over 4 plus x squared from negative infinity to positive infinity. So, solution, the integral of dx over 4 plus x squared from negative infinity to positive infinity. So, we are going to apply the definition 3. So, our c here is 0. So, the limit of the integral dx over 4 plus x squared from 4 to 0 as a approaches to negative infinity plus the limit of the integral dx over 4 plus x squared from 0 to b as b approaches to positive infinity. So, we are going to use the formula, the integral of dx over 4 plus x squared equals 1 over a times the inverse tangent of x over a plus c. This comes from using the substitution and the known derivative of the inverse tangent function. Our a squared in here is 4, so our a will become 2. So the integral of dx over 4 plus x squared is equals to 1 over a times the inverse tangent of x over 2 plus c. So now we are going to apply the definite integral and the limits. The limit of 1/2 times the inverse tangent of x over 2 from a to 0 as a approaches to negative infinity plus the limit of 1/2 times the inverse tangent of x over 2 from 0 to b as b approaches to positive infinity. And that is equals to 1/2 times the inverse tangent of 0 over 2 minus the limit of the inverse tangent of a over 2 as a approaches to positive infinity as a approaches to negative infinity plus 1/2 times the limit of the inverse tangent of b over 2 minus the inverse tangent of 0 as b approaches to positive infinity. So equals 1/2 times 0 minus pi over 2, 0. and that is pi over 4 plus pi over 4 is equals to pi over 2. So the integral of dx over 4 plus x squared from negative infinity to positive infinity is pi over 2. The limit exists, therefore it is convergent. Therefore, it is convergent. Now for our last item, we have the integral of dx over x minus 4 from 0 to 5. Solution: the integral of dx over x minus 4 from 0 to 5. So we are going to split the integral. So this will become the integral of dx over x minus 4 from 0 to 4 plus the integral of dx over x minus 4 from 4 to 5. So this split is necessary because the integrand 1 over x minus 4 is undefined at x equals to 4, so making this an improper integral. Then we are going to express it as limits. Each part becomes a limit approaching to 4. So the integral of dx over x minus 4 as from 0 to 4 equals to the limit of the integral dx over x minus 4 from 0 to t as t approaches to 4 from the left, and the integral of dx over x minus 4 from 4 to 5 equals to the limit of the integral dx over x minus 4 from t to 5 as t approaches to 4 from the right. So the integral of dx over x minus 4 from 4 to 5 is equals to the limit of the integral dx over x minus 4 from 0 to t as t approaches to 4 from the left. So the integral of dx over x minus 4 from 4 to 5 is equals to the limit of the integral dx over x minus 4 from 0 to t as t approaches to 4 from the left, plus the limit of the integral dx over x minus 4 from t to 5 as t approaches to 4 from the right. Now let us evaluate the antiderivative. The integral of dx over x minus 4 is equals to ln of the absolute value of x minus 4 plus c. So using this, let us apply the limits. So the limit of ln of the absolute value x minus 4 from 0 to t as t approaches to 4 from the left, plus the limit of ln of the absolute value of x minus 4 from t to 5 as t approaches to 4 from the right, the limit of ln of the absolute value t minus 4 minus ln of the absolute value 0 minus 4 as t approaches to 4 from the left, plus the limit of ln of the absolute value of 5 minus 4 minus ln of the absolute value of t minus 4 as t approaches to 4 from the right, and that is equals to negative infinity plus the positive infinity. So the integral of dx over x minus 4 from 0 to 5 is equals to negative infinity plus the positive infinity. So the limit does not exist, therefore it is divergent. That's all for today. I hope you learned something from me. Thank you for watching and God bless us all.